Hello and welcome to this session in hypothesis testing for a single population mean using T-Statistic. I'm your instructor Rajesh Durbala and I'm an assistant professor in business analytics and research methodology. So what are we going to do today? That's quite simple. We are going to study hypothesis testing for a single population using the T-Statistic. That is in case when the small random sample, when the sample size is less than 30. Okay. That's quite simple. There are certain conditions, prerequisites to be followed or fulfilled. That is, when a researcher draws a simple random sample and the sample size is less than 30, okay, and we are using the small little sample size less than 30 to estimate the population mean, that is mu. So this sample size, which is quite small, less than 30, would be used to estimate the population mean. And when the population standard deviation is also unknown, and the third is the population is normally distributed. Under these three circumstances, T can be applied. Okay, so should I recap the entire thing? Number one, the sample size has to be less than 30. Number two, the standard deviation of the population should be unknown. Number three, the population should be normally distributed. Under these three circumstances, you can apply the T-test. And how do I calculate the T? T is represented by x bar minus mu divided by s divided by under root n. Okay, so x bar is the sample mean minus mu is the population mean divided by s. S is the standard deviation for the sample divided by root n. N stands for the sample size, which is obviously less than 30. Moving ahead, let's solve a problem. This is an example problem provided to you. Royal Tyres has launched a new brand of tires for tractors and claims that under normal circumstances the average life of the tire is 40,000 kilometers. A retailer wants to test this claim and has taken a random sample of 8 tires. You can see that 8 tires. Okay, 8 tires is the sample size, that is n, obviously, which is less than 30. He tests the life of the tires under normal circumstances. The results obtained are presented in the table. Now you can see the claimed value. The claimed value is always the population mean. So the claimed value over here is 40,000 kilometers. That is what the claim is made by the Royal Tire. Now the retailer wants to test this. Now let us see. I can see in this table I have 8 different tires: 35,000, 38,000, 42,000, 41,000, 39,000, 41,500, 43,000, 38,500. Okay, this is the life of sample tires. Now, this is how I frame my null hypothesis. My null hypothesis says H naught, that's mu, equals to 40,000, and alternate hypothesis would be mu that's not equal to 40,000. Okay, so you understand how do we write the null and alternate hypothesis. Null hypothesis has always to be the equality. Okay, so as my mu, that is the population parameter, is 40,000, I would state it as it is, mu equals to 40,000. My alternate hypothesis would be mu is not equal to 40,000. That's what the retailer thinks. He needs to test it whether it's 40,000 or more than 40,000 or less than 40,000. Okay, now the tabulated value for T at the given level of significance is 2.365. that is the significance level of 5%. Okay, we are doing a two-tailed test. You can see in the alternate hypothesis we have mentioned as not equal to. So when it's not equal to, we are going to test it on both the tails, the right tail as well as the left tail. So the T for 5% level of significance is going to be 2.365. Now the sample standard deviation, the S, is given to be 2618.6761 and sample mean x bar equals to 39,750. Now mu equals to 40,000, n equals to 8, and remember in this we are always going to go for degrees of freedom. Okay, in t-test you have to look for degrees of freedom. Degrees of freedom is always n minus 1. N over here is 8, So 8 minus 1 equals to 7. So when you are looking for the tabulated t value, you have to look for the degrees of freedom. You can see in this, in the 5% level of significance, this 7 denotes the degrees of freedom. In the table, I will look for 7 degrees of freedom. Okay, so here I can see n minus 1 equals to 8 minus 1 and 7 degrees of freedom. Now the tabular t value at 7 degrees of freedom for 5% level of significance is going to be 2.365. You can find it in any standard statistics book. You will find this value. Okay, that's not at all a problem. You can find the t table and look for the t value at 5% level of significance with degrees of freedom at 7. This is going to be the value. Now the t formula for testing, x bar minus mu divided by s root n, that's equal to 39,750 minus 40,000 divided by 2618.61 divided by root 8. That gives me minus 0.27. Okay, so when it's minus 0.27, it's quite obvious that it's going to be in the left side of the mean. If I put it on the normal distribution curve, it's going to be on the left side of the mean. Okay, but can you observe one thing? This 0.27, okay, 0.27 is much less than the tabulated value. So since it is much less than the tabulated value, it's going to lie within the acceptance region. So once it is in the acceptance region, what's going to happen? We have to accept the null hypothesis. Let's look at it. Now you can see this area, this entire white region is the acceptance region, and this gray region, this is going to be the rejection region. Okay, so my t value, calculated t value, that's 0.27, it lies within the acceptance region. So once it is in the acceptance region, what do? I accept my null hypothesis, right? That's it for today. You can reach me at LinkedIn, Facebook, Twitter, and this is my email ID, rajeshdorbal@gmail.com. You can also follow our page. We have an organization that's Let Peace Proliferate. You can visit facebook.com/letppro. This is an organization where we are fighting against extremism and intolerance. We conduct a lot of online and offline events. You have any feedback regarding this or any inputs you want to share your story, do visit our Facebook page, like us, share it, comment it, and I would love to listen to you in the comments. So once you watch this video, do write your comments, and thank you and listening to me. Hope to see you soon. Thank you.